Okay, hello guys. We're going to be talking about 4.1.8 today. So, you guys are going to be going through this and like pausing the video and doing your own notes. So, I'm going to try to help you do all of those things. So, on the first page, we're talking about investigating the inequality of x plus 1 or x plus y is greater than or equal to 1. So we're going to test each circled point to see whether it's a solution. A solution means that it would be like an answer to our problem or an answer to our inequality. So if we do that, all we're going to do is test some points. So if I start with this first point right here, that point is over 0 up 2. So if I do that, remember this is my x and this is my y, so I could plug those into my equation and get 0 plus 2 is greater than or equal to 1. So is 2 greater than or equal to 1? I would get a yes. So I'm going to color it blue because it is a solution. Okay, the next point I could do like maybe this guy just because he seems easy. So I could say over 2 up 0. Then if I plug that into my equation, it would be like saying 2 plus 0 is greater than or equal to 1. So is 2 greater than or equal to 1? Yes, it is. So it is blue. If I keep kind of going in my same style here, this point is over 0, negative 2. So if I plug that in, I got 0 plus negative 2 is greater than or equal to 1. Is negative 2 greater than or equal to 1? No, it is not. So I am coloring it red. Sorry, it's after school. Anywho, moving on. The next one. So this point would be over negative 2 up 0. So it's going to be the exact same as this if I plug it in. So it's going to be the exact same thing. So is negative 2 greater than or equal to 1? No, it is not. So it is red. So I'm going to pause the video and let you guys take a second to fill in the rest of your colors. When you're ready to double check your answers, play the video again, and then you can double check your answers and we'll start from there. Okay, so here's our finished answer. So we have a bunch of red dots and a bunch of black dots. So if I were to draw a line down the middle, this would be like saying, okay, anything that is above this line is a solution, is a yes, and anything below this line is a no. So basically, it's like remembering from when we had all of our inequalities on a number line, where we had a number like 7 or something, and we had a 10 over here and a 0 over here, and we would say, okay, this is like an open or closed circle, it doesn't matter which one for right now, and we would test 0 and see if it was a solution, and if it was, we would shade it. This is kind of the exact same thing. So all of these numbers up on the top were solutions, so we would be shading in everything on our graph. So we're kind of marrying together two ideas. So on the next page, we're going to look at how we're going to notate things. So the graph of a linear inequality is a half plane. It's called a half plane. So back on the last page, I showed you guys that if we put a line on a graph, we're going to end up shading half of the coordinate plane. So that's all that means. To graph a linear inequality, follow these steps. 1, graph the boundary line using the most appropriate method, so slope, intercept, point slope, or standard form, basically anything that we did on the last test. Then remember to decide whether the line should be solid or dashed. So before, we had to say open or closed circle. So if we had less than, that was an open circle. If we had less than or greater than 2 or equal to, that was a closed circle. But now we're kind of thinking, okay, we're not graphing on a number line, we are graphing on a plane. So I need to have a dashed line or an open line. Okay, dashed line or an open line. And we want to test a point to shade. And you guys know my favorite number in math is always 0, so the point that we always want to test is 0, 0. If 0, 0 happens to be on our graph, though, we should test maybe like anything to do with a 1. So like 1, 1, or negative 1, negative 1, or anything that has to do with a 1. Okay? So first example, graph each inequality. Y is greater than 3 halves x plus 1. So in this equation, we're in slope-intercept form. So we're going to figure out, okay, our m is right here. It is 3 halves. Our y-intercept is positive 1. And our line, what this means is it going to be dashed or shaded? In this case, we have a greater than sign, so it is going to be a dashed line or an open line, if you want to think of it that way. So to graph in this form, we graph the y-intercept first, so we're going up positive 1 on the y-axis. And then we're going to use our slope of up 1, 2, 3, to the right 1, 2. And then we got to keep going because I make you guys do that. So up 1, 2, 3 over 2, up 1, 2, 3 over 2. Then we need to get the other side of our graph, so down 1, 2, 3 over 2, down 1, 2, 3 over 2, down 1, 2, 3 over 2. And now we need to make our line, but when we make our line, we need to remember that it is dashed. So I'm going to go through and make a pretty straight dashed line. But I'm not done yet because since it's an inequality, we have to shade. So I need to test to shade. And in this case, 0, 0 is pretty darn close to my line, right? So I don't want to actually use 0, 0 in this case. I might want to use something that might make it a little bit easier for me to get a for sure or definitive answer. So I'm going to pick this point right here, over 0 or over 1 up 0. So when we test, we always test into the original equation. So I get 0 is greater than 3 halves times 1 plus 1. So I got 0 is greater than 3 halves plus 1. So is 0 greater than 1 and 3 halves? No, it's not. So do I want to shade that direction? No way. So I'm going to shade above the line. And I'm going to color my whole graph because if I have to graph the entire graph, I'm going to shade the entire graph. Pretty beautiful. And that is my final answer. My whole answer is the graph itself. So now I'm going to move to the next one. Again, we're in slope-intercept form, so I'm going to fill in everything that I know. So I know my slope is 2. I know my y-intercept is negative 4. And my line this time is going to be a solid line because it is less than or equal to. So if I graph, I go negative 4 on the y-axis. 1, 2, 3, 4. And then I'm going to go up 2 over 1, up 2 over 1. Up 2 over 1, up 2 over 1. And then down 2 over 1. So I'm going to get all my points on my graph, and then I'm going to add in my solid line this time. And I'm not done. Since it's an inequality, I need to test. And this time 0, 0 is looking pretty good. It's not that close to my line. So if I plug that in, 0 is less than or equal to 2 times 0 minus 4. So is 0 less than or equal to negative 4? No, it is not. It's actually greater than. So I do not want to cover up 0, 0. I want to go the other way and shade the entire right side of my coordinate plane. So beautiful. Make sure you're shading as beautifully as I am right now. Booyah. So let's try one on your own. So I'm going to pause the video. You guys need to pause the video, and you are going to try this one on your own. Once you're done, come back and check your answers. Okay, so here's your final answer. Notice how I didn't do any baby shading. I went all the way across my graph, just like I normally would expect you guys to, and I used a dashed line. So hopefully you did that as well. Let's try the next one. Now I just need to graph this inequality. This is not in any of those forms, right? It's not point slope, it's not standard, it's not slope intercept form. This is just any old y equals problem. So we need to plot our point where y equals positive 4. So we're going up positive 4 on the y-axis. 1, 2, 3, 4. And then I need to figure out if I'm going to have a dashed or a solid line. Since it's not equal to, we are going to have a dashed, whoops, if I can spell, dashed line. Then I'm going across because y equals always gives me a horizontal line. So do I still need to test? You betcha I do. And I'm going to test 0, 0. So is 0 less than 4? Yes. So I'm going to shade the bottom all the way across. Booyah. Looking good. And the next one that we have to do is an x equals problem. So anytime that we have an x equals, we need to go on the x-axis at that number. So in this case, it's -2. And on my line, I'm going to have a solid line. Anytime we have an x equals problem, it is a vertical line. And then I need to test to figure out which way to shade. So I need 0, 0 again, because that's my favorite number. So is 0 greater than or equal to -2? Yes, it is. So I'm going to cover up 0, 0 and shade everything to the right so beautifully. You're so good. Okay. So hopefully you guys can go back through this video and double check and see if you have any questions with anything. Your homework is independent practice 4.8.1, number 1 to 16, 19 to 20. Yes, you have to do all of them. Please don't complain about that to the sub, because I'm sure they're a very nice person. Good luck. Good luck.